Probability trees. A probability tree diagram is used to represent probabilities using two or more stages. Let's have a look at an example. A bag contains 5 red and 3 blue balls. A ball is chosen at random. It is then put back into the bag and another is chosen. Show this information on a diagram. Now, before I show this information on a diagram, let's have a look at the probability of choosing a red ball, which is 5 out of 8, because there are 5 red balls and there are 8 all together. Then the probability of choosing a blue ball is 3 out of 8, because there are 3 blue balls and then there are 8 all together. Now, because the ball is put back into the bag, the probability of the second pick is going to be the same, 5/8 and 3/8. Now, this is what the probability tree will look like. Let me explain it. Now, these lines are used to show the choices available at each stage. The outcome is shown at the end of each line, and the probability is shown at the centre of the line. So there's 3/8 for blue and 5/8 for red. So once you've chosen your first ball, and you've got two different outcomes, a red or a blue, you do it all again for the second ball. So if you chose a red ball for the first ball, you can then choose a red ball for the second ball, probability of 5/8, a blue ball for the second ball with a probability of 3/8, or if you had chosen a blue ball as your first ball, then the probability of getting a red ball for the second ball is 5/8, and the probability of getting a blue ball for the second ball is 3/8. So this probability tree diagram shows you the choices that could have been made. So you could have got a red ball and then a red ball, a red ball and then a blue ball, a blue ball, then a red ball, or a blue ball and another blue ball. So to recap, my final outcomes could have been a red and a red, red and a blue, blue and a red, or a blue and a blue. In probability, there are two very important words. We have and, which means multiply, and we have or, which means add. With that in mind, let's have a look at a few questions based on the probability tree drawn. So remember, and means multiply and or means add. So let's find the probability that the balls chosen are both red. So the probability that the first ball will be red is 5/8, and as the ball is replaced, the probability that the second ball will be red is also 5/8, which we can see from our probability tree. So if we're looking at the probability that a red and a red is drawn from the bag, you multiply. So we have 5/8 multiplied by 5/8, and that gives us the answer of 25/64. Let's have a look at another question. So we have to find the probability that the balls chosen are the same colour. So that means we could have a red and a red, or a blue and a blue. And remember, in probability, when you see the words and or, we use these signs instead. So let's go through this. So the probability of getting a red is 5/8, and another red is multiplied by 5/8, or, which is plus the probability of a blue, which is 3/8, and multiply our probability of a blue is 3/8. So tallying that up, we have 5/8 times 5/8, which is 25/64. Then we have 3/8 times 3/8, which is 9/64. And when we add these two together, we get 34/64. So that is the probability that the balls chosen are the same colour. Often it is good practice to fill in the probability for each final outcome at the beginning, like this. It makes it a lot easier whenever we come to answer the questions to already have the probabilities of each outcome worked out. So that's, for example, is 5/8 times 5/8, which is 25/64, and so on. Also, in probability, you should know that all the outcomes should add up to 1. So it is good practice to check that these 4 probabilities, as these are the only 4 options, that they add up to 1. So we have 25/64 plus 15/64 plus another 15/64 plus 9/64 is in fact 1. So therefore we have done our multiplications correctly. Let's have a look at another example. So Sunny drives through 2 sets of traffic lights. The probability that it is red is 1/7. The probability that it is amber is 2/7, and the probability that it is green is 4/7. Now this is the same probability for both sets of traffic lights. This is what the probability tree will look like. Now you can see, as there are 3 different choices, red, amber and green, we have 3 branches. So let's fill in our probabilities on each branch. So for the red, amber and green, we have 1/7, 2/7 and 4/7. And as the second set of traffic lights has the same probabilities, let's fill those in too. Now remember, these are all the different outcomes that could happen. So we could have a red and a red light and then an amber light, a red light, then a green light, an amber light, then a red light, and then so on. So these are all my 9 possible outcomes listed below here. And the probability of each of those outcomes, which we get by multiplying each branch together. So we've got 1/7 times 1/7, which would be 1/49. 1/7 times 2/7, which would be 2/49, and so on. They are here. So now that we have our 9 probability outcomes, let's look at a question. So what is the probability that at least one light will be green? So that's at least one light will be green. We could have red and green. We could have amber and green, green and red, green and amber, and we could also have green and green, because it says at least one, so that could be one or more. So because we could have red and green, or amber and green, or green and red, or green and amber, or green and green, because I'm using the word or, I add these 5 together, and that will give me my probability of 40/49. Now it's your turn to answer a question. Pause the video and try this. How did you get on? Here are the answers. If you answered any of them incorrectly, have a look back through the video and then try again.